Good evening. Hope everyone's doing fine. Alright, I'm going to go through some skills on the second study guide for fractions, number theory. Alright, I'm going to do this quickly. There's so many things on here, but hopefully it will help explain all these different terms and different skills on it. Alright, you can see what they should know how to do after going through all these different skills, finding the least common multiple of two or more numbers representing fractions on a number line, finding equivalent fractions for a given fraction, writing fractions in simplest form, compare fractions, decimals, whole numbers, and mixed numbers. And I've tried to give an overview of each skill, but I'll go through them quickly with you. Hopefully it will help. Now, least common multiple is often indicated by these three letters, LCM. When you or I were in school, we never concentrated on the word multiple. We found the lowest common denominator. But basically the same thing. You find the multiple to find the denominator. I'll show you how this is used. If I had this fraction here, 1/2 plus 5/8. You can't add unlike fractions. Just like if I had 3 donuts and 2 dozen donuts and I wanted to know how many donuts I had, I would have to convert my 2 dozen to individual donuts and then I could add them. Same way here, I can't add eighths and halves. So what I do is I find a number that 2 and 8 will go into, and that is a multiple. A multiple is a number I get when I multiply 2 or 8 by some other number. If I multiply 2 times 1, I'll get 2. Well, 2 is a multiple of 2. 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. And it goes on forever. Alright, 8. You multiply 8 times 1, I get 8. 8 times 2 is 16. 8 times 3 is 24. On and on forever. Alright, so the lowest number that 2 and 8 will go into is 8. So one method that you can use to find the lowest common multiple is by listing the first 5 or 6 multiples of those numbers. That's great when you have small numbers like we've got here, 2 and 8. But you've got a problem when you start having fractions like this. If you had something like, let's see, I'll use 5/8 again. Well, let's say your next fraction is 4/15. All right, and I have to find a common denominator before I can add 15ths and 8ths. So I'm going to do my first method first, and I'll show you some other alternative methods that may help. All right, what you can do, I can say 8 times 1 is 8, 8 times 2 is 16, 8 times 3, 24, 8 times 4, 32, 8 times 5 is 40, and let's see if I can get a match with my multiples of 15. 15 times 1 is 15, times 2 is 30, 3 is 45, 4 is 60, okay, 5 is 75. Well, I hadn't got there yet. So at some point, I've got to either keep on going until I find a number, or I can use some alternative methods. Now, let me just say this first. You can always find a common multiple by multiplying these two numbers together. All right, 8 times 15 is 120. That's a common multiple. So you can always do that. If you just want to find a common number that 8 and 15 will go into, you can always multiply them together. It may not be the lowest, but you can use that method. All right, but let me show you a couple of other things that's on this study guide, and hopefully my examples will help make it easy to understand. All right. One thing I can do is do a factor tree again. This is why I beg these students to pay attention when I do factor trees. All right, my numbers were 8 and 15. So I'm going to do quick factor trees on 8 and 15. All right, remember when you do a factor tree, all you're doing is breaking each composite number into only a product of primes. A composite number has other numbers other than 1, and the number itself doesn't go into it. A prime number only has 1 and the number itself. So 8 has other numbers that can go into it. 2 times 4 is 8. 2 is prime, so I'm done with that. 4 is 2 times 2. So what I've got here is the prime factorization of 8. 2 times 2 times 2. All right, here's 15. 3 times 5 will give me 15. Well, is 3 prime? Yes, it is. Is 5 prime? Yes, it is. So there's the prime factorization of 15. Now, to use prime factorization to find least common multiple, this is all you do. You find the greatest number of each prime that is listed in either of my entries. Well, I've got 2's, and I've got 3's, and I've got 5's. Well, what's the greatest number of 2's that I have? I have 3 2's, so I'm going to write that down. What's the greatest number of 3's I have? I have 1. What's the greatest number of 5's? I've got 1. The product of those prime numbers, 2 times 2 times 2 times 3 times 5, will be my least common multiple. And in this case, it is 120. All right, so that works very quickly if the students can do a factor tree. If they can't, they've got a problem. All right, let me do another one real quick. All right, let's say if I had to add 3/7 plus, let's say 4/8. Oh, well, let's do 5/8 again. All right, now, it's should be obvious that I can multiply 7 times 8 and change these to 56. Now, I'll show you how to do equivalent fractions in just a moment. All right, so 56 is the lowest common multiple. Well, let's see if it's the lowest one. Well, I'm going to do a factor tree on 7. Well, it's already a prime number, so there's nothing you can do. It's 1 times 7. All right, here's 8. 2 times 2 times 2 again. I just did that one. So what is the greatest number of each prime you see in both lists? I see a 7 and 3 2's. So 2 times 2 times 2 times that 7 is 56. Okay? All right, now let me do one that may not be quite that apparent. Let's say if I've got 7 over 15, 9 over 10, and I'm going to add those. All right, what number will 10 and 15 both go into? Now, once again, I can list all my factors, all my multiples. I could say 10, 20, 30, 40, 50, and so on. Well, I could do 15, 30, 45, 60, and so on. Well, I still don't see a match. Now, if I go one more place, I've got a match. But see, sometimes you don't know how far you've got to go. So I'm going to do factor trees on 15 and 10. 15 is 3 times 5. Very simple. 10 is 2 times 5. And I'm done. Now, let's find the greatest number of each prime that I see in both of my lists. Okay, I see a 2. That's the greatest number of 2's. I see 1 3. That's the greatest number of 3's. I see 2 5's. So I'm going to write those down. Because I write down the greatest number of primes in either list. Now, what is 2 times 3 times 5 times 5? Well, let me see. I'm sorry. Can't see what I'm doing. The greatest number of 5's is one of them. I'm sorry. I can't see what I'm doing. I'm so close to it. There. That's better. Okay. 2, because I've got 1 5 here and 1 5 there. So I've got 1 2, a 3, and a 5. So 2 times 3 times 5 is 30. So my least common multiple, the smallest number that 15 and 10 are going to, is 30. So you can see how you can do that quickly. So once again, let me go back through this, make sure you understood what I did. You do a factor tree, 3 times 5, 3 is prime, 5 is prime. 10, 2 is prime, 5 is prime. The greatest number of 2's I see in either list is one of them. The greatest number of 3's I see is one of them. The greatest number of 5's I see is one of them. Multiply those together, get that product, and your least common multiple is 30. Now, once again, you'll be using that when you add or subtract unlike fractions. Okay? Now, go to the next skill real quick, and it won't take long on some of these. How do you find fractions on a number line? Well, the first thing you do is decide between what whole numbers is that fraction between. I've given you some examples. These are your benchmarks here. In other words, you need to decide if the fraction given to you is greater than a whole number, less than a whole number. Decide what it's between, and that will help you pinpoint where it's going to be. So I've given you some examples here. I've labeled this number line in eighths, all right? But sometimes you're not given eighths. All right, you may be given something like 16ths. All right, so you have to make some adapt somewhat when you have that. But basically, this is what you're going to do. All right, let's say if this thing has not been labeled. Let's say it's been labeled into fourths. All right, I'm just going to highlight mine, every other fourth. Okay? All right, but let's say I've got to determine where 2/8 is. Well, 2/8 isn't on here, but I know it's going to be somewhere between 1/8 and 3/8. All right, one thing you can do is another skill that we're going to learn. You can simplify it. Find a number, a factor that will go into both numbers. It's 1/4, and then you can pinpoint it. If you don't have a fraction that can be simplified, sometimes you just have to make adjustments and estimate where it might go. So I'll give you one of those. Let's say if I had 1 and 9/20. A 1 and 9/20 is about, and the students have learned this, to look at a fraction and decide if it's a little less than a half or maybe a little bit bigger than a half. Well, 9/20, you're comparing the top number, your numerator, to your bottom number, your denominator. 9 is almost close to half of 20. So if I had to pinpoint where 1 1/2 is, 1 and 9/20 is on this number line, it's going to be somewhere near 1 1/2. I know it's going to be bigger than 1, and it's going to be smaller than 2. So it's going to be somewhere between this and this whole number. Since 9/20 is about a half, I would put my dot somewhere right in there because it's going to be a little less than 1 1/2. All right, now if you had a mixed number, let's say if you had something like this, and I'll show you a little more of these later. Let's say if you had 19/8. You can't really do that until you've converted it to that improper fraction back to a mixed number. And the students have been shown this. Divide the bottom into the top. 8 goes into 19 2 whole times. Subtract. Take that remainder, whatever your remainder is, and put it back over your original divisor. So my mixed number equivalent is 2 3/8. So if I had to pinpoint 2 3/8 on this number line, it would be somewhere past 2. Okay? Now, let me get to equivalent fractions, because this is where the students will have to know what to do if they have a fraction like 1/2 plus 5/8. But your rule is very simple. To find an equivalent fraction for any given fraction, and I'll use 1/2. All you have to do is multiply the top number, the bottom number by the same number. I'm going to multiply by 2. 1 times 2 is 2. 2 times 2 is 4. So an equivalent fraction is 2/4. All right, let me do another one. 1 times 3 is 3. 2 times 3 is 6. And we all know that 2 out of 4 and 3 out of 6 is still a half of something. If I ate 2 out of 4 pieces of pizza, I've eaten half. If I eat 3 out of 6 pieces of pizza, I've eaten a half. All right, so let me do one more. Let's say if I've got a half, and I'm gonna multiply it by 13. Okay, 13 over 26. If I eat 13 out of 26 pieces of candy, I've eaten a half. So to find an equivalent fraction, simply multiply the numerator and denominator of the fraction by the same number. Now you say, what's that got to do with this? Well, I'll show you. When you're adding or subtracting fractions that don't have the same denominator, you've got to change them to the same denominator, like I did in the first problem. So I have to use the skill listed above. I have to find a common multiple, a number that 2 and 8 will go into. Well, What will 2 and 8 go into? Well, I've shown you that earlier. 8. Now this is where you have to use the skill of finding the equivalent fraction. I want to change halves and eighths to eighths. Well, how do you do that? By multiplying the numerator and the denominator by the same number. But you have to ask yourself, well, how do I go from 8 to 8? Well, that's simple. I multiply by 1. Whatever I do here, I do the same thing there. So 5 eighths is 5 eighths. Now, what is 1/2 in eighths? Well, how do you go from 2 to 8? Well, I would multiply by 4. Whatever I do here, I do here. So 4 eighths. Now, I can add my like fractions. I've taken unlike fractions and made them the same. 4 plus 5 is 9. Your numerator is 9 now. Your denominator stays the same. So 9 eighths. And then I use my other skill of how to change improper back to a mixed. 8 goes into 9 one whole time. Take my remainder, put it over my divisor. So 9 eighths is 1/1. So there's your answer. All right. So, once again, there's reasons students are learning all these skills. It's not just to say, well, I can find an equivalent fraction. There's times when they have to be able to do it. All right, I'm going to do one more problem, and then I'll get down to some of this other real quick. All right, I'm going to add, well, I'm going to subtract this time. I'm going to subtract 11 over 23 minus 7 over 46. Let me make this top number a little bit bigger. I'm going to make this 19 over 23. Okay, now, first thing I would have to do is find the common multiple. I have to ask myself, well, what will 23 and 46 go into? Well, I've told the students another thing. Always ask yourself, will that little number go into the big number? Because sometimes it will. If I listed the multiples of 23, 1 times 23, 2 times 23, 3 times 23, excuse me, 4 times 23. All right, I'm going to find out real quick the multiples of 46, 1 times 46. Oh, there it is. There's my least common multiple. So I've already found it. But if I did factor trees, I'm going to do the same thing. If I did a factor tree on 23, I'm going to get 1 times 23, because 23 is prime. There's nothing else to go in 23. Now, how about 46? Well, this one's easy. 2 times 23. 2 is prime, 23 is prime. Now, using the method I learned a minute ago, I write down the greatest number of each prime that's in both my lists. I have a 2, 1, 2, and I have 123. 2 times 23 is 46. So there's my common multiple, which is also my common denominator. So now I'm going to change them to 46. Now I use my skill on finding equivalent fractions. 46 times what is 46? 1. 7 times 1 is 7. Excuse me. How about this? 7 times 1 is 7. There you go. Alright, now I'm going to change this to 46. Well, how do I do it? How many times will 23 go into 46? 2. Whatever I do here, I do there. Now, I've got 46. Now I can actually subtract it, because all I do is to subtract the numerator minus the numerator. 38 minus 7 is 31 over 46. So you can see all these skills are intertwined. Now, I'm going to leave that fraction up here, my answer to that problem, to show you the next skill. But the next skill is something they have to use in every area of fractions, mixed numbers, and so on. It's how to simplify a fraction. Alright, I'm going to put this one up here, make it a little bit bigger, because this will bring both skills that we've covered several times over the past several days. Alright, to simplify a fraction, here's your rule. A fraction is in simplest form when the only number that will go into the numerator and the denominator is 1. That's when you know if it's in simplest form. Well, let's look at these numbers. I want to find anything that will go in 31 and anything that will go in 46 that they have in common. Well, I've spent hours and hours talking with the students about how to identify primes and composites. We've talked about divisibility rules, we've talked about doing factor trees, and so on. The students should know that 31 is a prime number, because there's nothing that'll go into 31 except 1 and 31. Nothing. 46, the students should know that 2 will always go into a number that ends in 6. We've spent hours talking about that. So the numbers that will go into 46 are 1 and 46, 2 and 23. Now, what do they have in common in those lists? Well, the only thing I see is 1. So if the only thing a fraction, a numerator and denominator have in common is 1, you know it's in simplest form. Okay, so that one is. So let's do one a little bit different now. Let's do, let's see here, 28 and 35, because that's the example that's on this. All right, let's say for our last to simplify 28 over 35. One thing I can do is I can write down all the factors of those numbers. I can write down every number that I know will go into 28. 1 and 28. Well, 2 will go because 2 goes into an even number. How many times will it go? 14. 3 won't go because I've got a rule that the students have had to memorize. 4 will go 7 times. All right, now let's do that with 35. 1 will go 35 times. 3 won't go, 4 won't go, but 5 will go 7 times. So there's the factors. Now let's look in our list. What do I see in both lists? What factor do they have in common? Well, they've got a 7 and a 7. Now if I divide by 7, I'm going to get 4/5, and that's in simplest form. Now, I'm going to show you a couple of other ways to do this, and it works every time. Some students are using this method, some are not. Let's say I have the same fraction, and I want to simplify it. Well, one thing I can do is I can do factor trees. I'm going to do factor trees real quick. 2 times 14, 2 times 7. All right, here's my prime factorization of 28. 2 times 2 times 7 is 28. Here is 35. That's pretty simple. Now, I'm going to mark out my prime numbers they have in common. They got a 7 and a 7. That's now, what's left? 2 times 2 is 4, 5. And I'm done. You can use factor trees to simplify. Very quick, very easy. Let me give you a little harder one. I'm going to make it obvious that it's going to work like this. All right, first of all, I could list all the factors of 36. So I'm going to do that. 1, 36. 2, 18. 3 and 12. 4 and 9. 6 and 6. All right, here's 54. 1 and 54. 2 and 27. 3, 18. 4 won't go. 5 won't go. 6 and 9. Now, what do I see in both lists? That's the biggest number. Well, I see an 18 and 18. Okay, that's my greatest common factor. But there's quicker ways to do this. I'm going to do a factor tree on 36. 2 times 18, well, 2 is prime. 18's not. 2 times 9. 2 is prime. 9 is not. Okay, I'm done. This is why I beg and beg and beg students to keep working with their times factor. The ones that are having trouble now are the ones that can't multiply through 12, because you have to use these skills every day. All right, 54. 2 will go. How do I know? Because it ends in a 4. 2 times 27. Well, we're going to 27. 3 will go. How many times? 9. 2 is prime. 3 is prime. 9 is 3 times 3. Now, let's look at it. What do they have in common? I see at least 1 2 in both lists. So they've got a 2 in common. What else do they have in common? I see at least 2 3s in both lists. Now, what is 2 times 2? I'm sorry, 2 times 3 times 3 is 18. So my greatest common factor is 18. Now, I don't always have to divide by my greatest common factor. I could have divided by 2 and kept going until I couldn't divide anymore. But you want to try to find your greatest common factor for a couple of reasons. By the way, this will be 2/3 is the final answer. The reason you want to try to divide or try to know how to find greatest common factor, 2 reasons. First of all, you can simplify your fraction quicker, but also on map testing and class testing, they'll just come out and ask you, what is the GCF of 2 numbers? All right, so if I had to do this fraction here, let's do 24 over 72. They may just say, well, what is the GCF of 24 and 72? Well, I need to know how to find it. All right, now I'm going to use another method to do that that's listed in this study guide. One method you can do to find the greatest common factor of 2 numbers is to divide. Now this is on your last study guide. I'm going to go back over. You can divide the little number into the big number. That goes 3 times. When you get a remainder of 0, the last number you divided by is your greatest common factor. So 24 is your greatest common factor. So to simplify this fraction, I'm going to divide by 24. And I'm going to get 1/3. Okay? All right, now, simplifying is probably the most important skill they have to know. You find the common factor, even if it's not, let's say if I had 100 over 200. You say, well, look, that's a half. Well, some students can't see that, believe it or not. Some students are having trouble finding greatest common factor, but they should know that 10 will go into both of these, that 2 will go into both of these, that 5. But let's say they just divided by 2. Well, you're going to get 50 over 100. Well, let's say the students still don't see that that's a half. They say, well, 2 will still go into that. You're going to get 25 over 50. They say 5 will go into 25, 5 will go into 50. So I'm going to divide by 5. And I get 5/10. I say, well, look, 5 will go into that. Okay, and I get 1/2. Finally, I got my answer after dividing by 5, by 5, by 2, and by 2. But I still got my right answer. But by finding greatest common factor, I could have known that 2 times 2 times 5 times 5 is 100. 100 is the greatest common factor. So if I would have divided by 100, I would have gotten 1/2 that quick. All right, now another thing they can do when there's numbers like this, and I'll show the students this. When you've got the same number of zeros in your numerator and denominator, you can literally just mark them out. Mark out one set here, one set there, and there's your answer. Okay? Now, the next section I'm not going to go into too deeply, simply because there's so many things that have to be accomplished with this one. I've tried to give plenty of examples, but I just want to tell you, you can't compare fractions, decimals, whole numbers, mixed numbers. You can't add them, you can't subtract them, you can't multiply them, you can't divide them until they're in the same form. So I'm just going to go through this. All right, so if I were given this problem here, now the students have seen problems like this on math testing. 3/4 plus 0.89. I can't add fractions and decimals. Even though they're both a number form of some other number, I've got to make them the same. So I've got to make a decision. Do I want to change my fractions to a decimal or my decimals to a fraction? It doesn't matter. It's whatever you think is easier for you. Now, if I were doing this one, I would change my fraction to a decimal. All right, now how do you do that? Well, there's a lot of ways to do this as well. You can always change your fraction to a decimal by dividing the bottom number into the top. All right, 4 into 3. You say, well, 4 won't go into 3, but yes, it will. If I add a decimal here, that's the representation of 3. Bring that decimal up and add a 0. 4 goes in, and now I forget about my decimal, it's gone. 4 goes into 37 times. Now the students have been shown how to do this as well. Subtract, what do I do now? Well, I add another 0. Adding zeros to the end of this does not change its value. 4 goes into 25. And we all know that 3/4 of a dollar is 75 cents. So now I can add it. Line up my decimal points. All right, and there's my answer. Okay, so obviously you've got to make them the same. Now, there's situations where you cannot change a fraction to a decimal. So let's say if I had 1/3 and 1.73. Well, I've got a problem here because 1/3, if I divide 3 into 1, just like I showed you a minute ago, to change a fraction to a decimal, divide the denominator and the numerator, look what I'm going to get. I'm going to get repeating 3s. I could work this problem the rest of my life and never get done because I'm going to get 3s forever. All right, so I've got to have an alternative method. So you can see, now the way to indicate it, something that goes on forever, use your bar or repeat the number at least twice so you'll know what's being repeated. All right, now, so in this case, I've got to change this to a fraction. So how do you do that? Well, once again, it's all in my explanation here. Let me get rid of some of this here so we can see what we've got. To change a fraction, a mixed number, or a decimal, to a fraction. First of all, I must say it to myself and then write what I say. That says 1 7/300. So I'm going to write down 1 7/300. Okay, I've written that decimal as a fraction. All you have to do is say it, then write it. Now, I'm going to add them. Well, what do I have to do? Let me get this lined up. Sorry, folks. Sometimes I cannot see where I am. Eyesight plus being so close to the board. Now I'm ready. I can't add unlike fractions, so I've got to find a common denominator. What will 3 and 100 go into? Well, they're both going to 300. So I'll convert them to that. 3 times 100 is 300. 1 times 100 is 100. 100 times 3 is 300. All right, then 73 times 3 is 219. Now I can add them. Okay? So there's reasons they have to know how to do that. Same way with comparing. Let's see if I've got this. 0.25 and 1/4. And the instructions say greater than, less than, or equal to. Which one? Well, first of all, I tried to get the students to memorize some of these. 25 hundredths is 1/4. So 1/4 equals 1/4. But let's say they don't know how to do that. They haven't got that memorized. They're going to have to do one of two things. They're going to have to change 1/4 to a decimal by dividing the bottom into the top. All right, I get 0.25. Or they're going to have to change the decimal to a fraction by saying it to themselves. That says 25 hundredths and writing it. And then you can simplify it. A common factor is 25. All right, I lost my Pro board. I'm up here on Saturday, January 21st, I guess it is, and we had the power went out briefly because of the weather, so I don't know if I'm going to get my Pro board back up, to be honest with you. My computer's running, but my Pro board is not coming on. So the power went out briefly, so I'm not sure if there's a problem with the hardware I'm using or what, but I'll keep talking for a minute because I'm almost done. All right, but I've given you plenty of examples there to use as far as comparing decimals, whole numbers, mixed numbers. I apologize because I don't like to stop, and I hope I didn't mess up my presentation here because I spent a good bit of time doing it. The only other thing that's listed on the sheet that you've gotten is adding and subtracting unlike fractions, and I've gone through that as best I can. Contact me if you have any questions, concerns about what you've seen here. Hopefully this will help you and your child better understand what we're doing. I encourage you to have your children read through their study guides every night. It's the only way they're going to be successful, because these things are getting so complicated. Some of the children have a good background in fractions. Some of them are just breezing through. Others are having trouble mainly because of their lack of knowledge of their times facts, which continues to be a problem. All right, contact me if you have a question or concern. All right, thank you.